This video is sponsored by Cubico. Alright, DIY Airplane Mark IV video part number 2. So a lot of things have changed since that last video. I'm feeling pretty good about this. The wings are on, they don't feel too heavy. Right now it's 14 pounds on each side. I'm really only expecting to maybe add another 8 pounds to each wing, and that's being pretty generous. So if I come out with that, I'll be really, really well set as far as the all-up weight of the airframe. Wings are sanded, everything's finished. We're attaching the vinyl covering, and this is highly unorthodox. But that's why I kind of like experimental aviation, and that's kind of also why I'm definitely reinforcing and sticking to the bit that I'm not releasing plans for this, because this is definitely interesting. This could potentially be fairly reliable wings for maybe like 2 or 3 years, or they could be completely disastrous if you leave it out in the sun and then, you know, it's all over in a couple days. This is fun. I like this because like I don't have a lot of money wrapped up in this. It's just really the aluminum that's just the most expensive part, and maybe the hot wired foam. So yeah, experimental aviation, yeah. Although we're in the ultralight class. All right, now the vinyl's down. I'm actually gonna slightly melt the foam and the vinyl and try to fuse the adhesives together as much as possible. I think this is really gonna keep this thing stuck down. I actually made a test piece a year ago, and it's actually still very hard to kind of separate this kind of method from each other. So this is working out pretty well. Well, it definitely doesn't look good, but hopefully it stays attached. Because like I'm more concerned about cheap and effective versus, you know, a high-speed finish. This is not a high-speed finish. This is not a high-speed airplane. I'm curious about this vinyl covering too and how much it'll weigh. So let's get a weight of the wing first. 19.8 pounds. That's actually not bad at all. This is a lot lighter than all my previous wings. Hopefully the vinyl covering, I'm only maybe expecting like 3 pounds per panel. So hopefully a flying weight of 23 pounds per panel. I will definitely be on track to making my light ultralight. 21 pounds even, so 20 pounds. So it looks like we're only out maybe around like maybe a pound and a quarter so far. That's just not that bad in just vinyl covering. So yeah, these will be very light wings when I'm done. All right, now we got the other side covered. It looks like it's 22 pounds on the scale. This is officially the lightest completed wing I've ever made for one of my crappy homemade airplanes. All right, let's do the other one, and then we can move on with the tests. These are the same sandbags I used last time I stress tested my third airplane design. It is now time for the wing loading test, because I did a bunch of TLAR engineering, that looks about right, which is horrible for airplane design. But luckily I have an airplane building experience, and I had some actual aero friends come and look at this thing. Plus I've actually used basic components that are used off of other traditional ultralights with the same weight class. So this should pass with flying colors, because everything is a lot lighter on mine than what I'm using. And we're gonna figure this out. Everything that's not lifted weighs about 100 pounds, and then I weigh about 150 pounds to just save it on the safe side. So that's 250 pounds. So if we get to 250 pounds in the wing, that's 1 G, so that's basic normal flying. If we double that, we'll get to 2 Gs. And that's still okay, it's whatever, it's good enough. 750, 3 Gs. 3 Gs is actually kind of a lot for an ultralight that flies on a calm evening. So we'll probably stop somewhere around here. We may go a little beyond 750 depending on how much sandbags we have. I don't think we'll get to quite to 4 G, because that's 1,000 pounds, and that's a lot of weight. Also, we're actually doing this a little bit differently. This is sort of incorrect, but I have a block here that we're setting the airplane on. Because the only thing that we're not really going to get a good test on is the fuselage itself, because the members that hold the wings up, they're going to be in compression rather than tension. So if my original plan was to cement it from the ceiling, however, I couldn't really get stuff up there to do that. So we're going to have to just do it this way and just stress test the spars, the wing struts, and the center part of the fuselage. We just won't be able to actually test the strength of this right here, which is the center part of the fuselage. Because in normal flight, it would actually be pulling itself apart rather than being compressed. All right, let's begin the test. right, well that's 1G. That's very obvious. It's going to survive that. Let's go to 2Gs. This is 2Gs. This is probably what the most I'll ever really realistically load it in flight to. I'm looking for compression here too, because this is loaded in correctly. Like this thing is being squished right now.
Right.
Typically it will be being pulled apart in flight. So this is a little different than how it would actually be loaded. Setting down the wing, and it's hardly deformed at all. No real flex in that at all. So we're gonna keep going. Getting heavy now. So we are at 900 pounds. So we're not quite at 4, but we're over 3. This is good enough for me, I'm happy. I want to measure deflection and then take the sandbags off and then see what we get. Okay, now it's being supported fully. That's a lot of weight for some styrofoam and some aluminum. I see some stuff going on in here.
It almost looks like it's bowing a little bit.
Look, it is bowing.
Is that why this is like
yeah, that's why
like
that's
that?
flexed out. This is in compression. But luckily it doesn't look permanent, so when I take this off, it should just go back to the way it was.
Yeah.
But the windscreen is being pushed out. All right, let's just take everything off. Well, the wing looks back to normal, just covered in a little bit of sand. Actually, that was a good test of the foam itself too, because there's actually no ribs or any sort of wood in here. And all that force was localized like within the center of the foam, where the spars are actually out here, but the sandbag was here, so all that was actually being sunk straight into the foam. So that's really impressive that with that pattern cut out in it, the truss shape, it was still able to survive that very easily and not buckle or crack or rip right out to the bottom. So we're definitely more than good to go, because a normal flight, when it's stressed out, it will be dispersed almost evenly across the surface. It really depends on your angle of attack, but that's just more airplane complexity stuff there. But I'm very, very satisfied with what I see so far. Don't get any ideas about doing this yourself yet. I have no idea how long this is actually going to last. This is a very, very big experiment. Lurking around the comments on the internet, it looks like I actually found some more information about this engine. It turns out someone actually got like communication from Vitarazi, which is the manufacturer of this motor, and it turns out this PSRU, or prop speed reduction unit, does not like being pulled on, such as my airplane, because it's in a tractor configuration. So unfortunately this is not going to have to work. So I had to pull it off and start from scratch basically. It turns out I actually have a friend, Paul from OpenPPG. He's been working on a single motor electric pair motor, and I thought, that's kind of cool. Maybe I should do electric again, especially because, you know, things have advanced in like the last 4 years since I did an electric ultralight. So now we're going to use something that's electric. Ooh. I don't want to do much more than that because of that crappy motor mount. I installed all the electronics and stuff and fired up the motor. It does work. Nothing exploded, fortunately. But I did find out I can fit the tiny propeller on the really big motor. The reason why I'm not using the big propeller is I'm still waiting on the motor mount. So I'm gonna check to make sure the amp meter works, and I'm gonna put a small load up by putting this propeller. It's gonna push the air backwards, moving in the wrong direction, but hey, at least I'll get to see the meter do stuff and confirm everything works before we go to the big engine. We're currently drawing 1 amp. 1 amp at 92 volts. 130 watts. Oh, here's the cool thing too, come over to this side. One thing I did just in case the, let's say the motor's running away. Oh no, I don't like this. Pull it and it just completely disconnects the system. So it's no longer running. Now, however, you do not want to get the smart idea of plugging this thing back in, because 92 volts without a spark suppressor, ooh, it's gonna make a big spark. I got the motor mount. Get some use out of that winch. All right, here we go. That was full power. I can't even pull it back. It sounds very smooth. I'm actually very happy. It doesn't terrify me. The funny thing is I didn't really mention this, but when I was using the old Moisture 185, this thing was like, shake it. This is really smooth, crisp, and clean with no caffeine. bolts are in the other planes. Cotter pins are in. Basically, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bolts and you're done. I don't really count the fairing to, you know, close the wingtip stuff. So it's literally just 10 bolts, put the pins in them, and we're good to go. I want to pre-flight it because obviously this is the very first time flying this, and you should really pre-flight any aircraft, but this one needs a thorough inspection because it's been trailered now. So I need to make sure everything's set, and then I'm going to start the taxi test, or the low altitude flying test. Probably I'm just end up flying it if it's too windy, because it doesn't have aileron, so I literally have to just go for it to keep the wings from touching the ground. All right, one last thing. Don't forget the IFAC kit in case I have a blowout because the propeller comes back and smacks me in the face. Clip.
This foam?
Yeah. Yep, all foam. All right, batteries are locked. Time to put on the aerodynamic bolt holder. That's what I'm calling this. It just weather vanes, and it should keep it from spinning if I think this works the way I think it's gonna work. The thing with this plane is it has no ailerons. If this was an aileron airplane, if I start getting too high off the ground, the wing starts rolling, I just flatten it back down with the aileron and just fly, you know, adjacent, like crabbing across the runway. This is an aileron, so if I get to that stage, I'll probably have to correct with rudder, but gain more altitude to keep the wings from touching the ground. So at that stage, I'm probably flying. So I'll either fly to the end and put it back down, or if it's too high, I just fly it and go around planes. All right, we're ready to go. Well, it flies. I forgot how to steer the airplane. I'm trying to move. I was like, oh wait, yeah, rudder. It's always better to err on the side of a nose-heavy airplane for the first couple of flights. But I think I could probably put a few pounds in the tail, so I'm gonna put this in the tail. I always try to make them just a little bit nose-heavy right off the get-go. Nah, I won't fall off.
I'll be weight different.
I'll barely probably notice this, but it's something. What I do is I need a gun, so when I'm flying, if the plane is too tail-heavy, I look back, I shoot the water bottle empties out its fluids, and then I resume nose heaviness, and I can continue flying. All right, y'all, really? Ready to see me fly? It was at full power the entire time. This thing does not make any thrust once it starts going kind of fast. I was like, max power is like just flying the verge, so I was like, yeah, we're going round and round and round. Back on the ground, get me on the ground, I want to be on the ground. Okay, we're back from the first flight. Yeah, that did not go as well as I wanted it to. The pitch speed of the propeller was a little bit too flat, meaning I couldn't really accelerate even with the throttle pegged at full power. The propeller was basically just turning as fast as it could possibly go. However, the oncoming airspeed was too quick. Also, one thing that I found really interesting, because I've never really flown a aileron-less airplane, this is basically a 2-axis control, was the rudder is extremely sensitive in like roll control as well. A lot better than I thought it would be, especially like if you look at one of these tests here. You'll notice that when I kicked the rudder over, it rolled a lot, and that was actually just induced by the coupling of the whole dihedral thing and where the rudder is and so forth. So it actually flew very well and actually satisfied my kind of requirements for control. The second thing that I noticed was the leading edge of the elevator, which is this surface here, was fluttering a little bit. This made me very, very, very nervous. I knew it might have been a possibility, I just didn't think it would happen at this kind of sort of airspeed, which is around like 35-ish miles an hour. So what was happening was I couldn't see it during the taxi test because I was more preoccupied in just flying down the runway. Now climbing away from that and actually getting some time to kind of pick up some speed, I noticed it was probably fluttering maybe around 3 inches from center line of deviation. It's a bit much for me, it makes me a little bit nervous, so I was like, okay, need to slow down, fly it on the edge of sort of the minimum kind of flyable speed I could fly it at, and just slowly bring it around and put it back down the ground, because we need to make some changes. So now that we know we need to change, we're gonna do it. The first thing I'm gonna do is lop off the old wing. I'm just literally gonna hot wire the foam cap off, then add 3 feet onto it. It's actually very simple because the way I've designed this wing, since it's just 2 aluminum bars, it's like a ladder style ultralight wing, so I literally just machine some spacers, slip the aluminum tubes in, put some glue on top, and just literally add more vinyl, and then the wing is done. That's it. I added a 3-foot extension onto the wing panel, so it's got a higher aspect ratio now, so it should fly better because there's hardly any penalty for adding any extra wing on, except for extra wing structure, but I did that by taking more aluminum tube and simply shoving it in. We've done a little bit more modifications. I added a wheel to my tail skid because I'm probably gonna do more taxi testing this time because I just hate dragging around. When I actually fly though, I'm taking that off because I like the brakes. And by brakes, I mean dragging the tail on the ground. We have a 3-blade propeller now for better performance. The propeller is more pitched because last time we were flying a plane in first gear. If you can kind of imagine this, it's basically trying to ride a bicycle at 30 miles an hour in first gear. You got to pedal really fast, but you're not really making any extra speed. There's a little resistance, but the motor's just turning very fast because I watched the amp draw go way down. Also, it's worth noting, I flew on 11 kilowatts of power. To put anything into perspective, because those are just numbers, my first plane had 25 available kilowatts of power, and I probably flew maybe around like 20-ish of that. So it's pretty good that it flew on 11 kilowatts. It should be even less with the increased wingspan, and with this prop with more pitch, I should get more kilowatts, and I put it on the meter, and I can generate, I think it's around 18 kilowatts now at full power, so that's better. Alright, I think we're all set. And my flight plan pretty much is to fly, but we'll see. If it feels really good, I'll probably just continue to climb and we'll just fly around. Alright. Well, it's not really quite that simple. So I did think about this ahead of time, like how I wanted to specifically handle a low speed, low performance airplane. Because a lot of you guys have pointed out, you need to fly that thing to 1,000 feet and then some so you can use that rocket parachute. Well, yes, but also kind of no. The weird thing about my airplane is it operates like in such a low performance category. It's like simply like it's below like 25 knots flying, and that's like flying fairly well too. It's not the fault that specifically kills you when you jump off a building. It's the sudden deceleration, and there's not a whole lot of energy, however, potential energy that needs to be absorbed somewhere. If I were to simply have a complete structural failure like below 50 feet, I probably give myself a 75% chance of survival. Maybe the rudder falls off or something catastrophic, maybe even a full wing collapse, which is highly unlikely in this case. 75% chance there of me surviving that. Now, here comes the issues. Like climbing from beyond like 100 feet to 1,000 feet, this puts me in a very weird area because it's high enough where I can get enough velocity to hit the ground very hard, and suddenly stop and also probably scramble my brains. Also low enough too that I have no time to literally throw the hand toss parachute, which probably needs a little bit more than 500, maybe even 1,000 feet to really successfully deploy. So I've kind of given myself like brackets on how I'd survive. And this is all if the plane does not climb very, very quickly. I'm going to stay kind of low because I'm thinking if it doesn't climb super well, I'll just stay low because I know it's safe down here and I know I have a fairly good chance of walking away. Because a lot of guys are using this metric of like a composite airplane or something that flies at like 80 knots at like liftoff speed. Anything below like 1,500, assuming the plane has a ballistic recovery system, which is a rocket parachute or something similar to that, you would have a very, very, very low chance of surviving if anything were to happen. And having altitude is your friend specifically in this case because it gives you more time to think if you were to have like an engine out or something like that. But a structural failure, all the energy's got to go somewhere. It's probably not going to end well for you. That's why I really have a slightly different flight plan planned for my ultralight. We should fly now. Really good. I'm so happy with that. Ooh, cruises around like 80, 90-ish amps or so. Flies at a nice, comfortable 30 miles an hour. It is the dream machine. It flies good. Ooh, we still got plenty of battery left too. Ooh, I'm so happy. It flies so good. Yeah, that was much better. Much more satisfying. perhaps the most satisfying ultralight I've ever designed and built and flown. It still didn't have as much power as I thought it would. I think I needed to advance the pitch of the prop just a little bit more. However, man, this thing flies great. I wasn't really sweating at all. It was just more just like a nervous laughter flying around like, ooh, I'm flying and this is great. So obviously I decided not to climb very high because, well, my climb performance was anemic, so I couldn't really climb out of that safe bracket because within that bracket of time I know you need to get out of there very quickly to be safe. So I figured, let's just fly it on low. I like to fly low and slow anyways, and this is what this airplane is designed to specifically do. So anyways, it's a 2-axis design. A lot of you guys keep freaking about that. I noticed it's like, yes, ailerons are great and all that. However, if you look back in the days of like the 1970s and early 80s, a lot of ultralights were 2-axis. To name a few designs, the Sky Pup and the Weed Hopper. They were both incredible airplanes, and I haven't really heard anything bad about those, so I knew it would probably be okay, and well, it's okay. It flies alright. Alright, so future mods. There are a few more things I want to clean up, such as like putting aerodynamic struts on there and sealing the gaps and stuff. But that stuff costs money, and this project was a very expensive project, considering all the batteries and electric motors and stuff. That's why I really would like to say thanks to Kiwico for sponsoring this video and making this possible. So a lot of you guys asked me, Peter, how'd you get so good at making things? Basically, when I was a kid, I tinkered around a lot. Tricopter thingy. This is the VTOL I've been working on. And that's why I'm very happy to have Kiwico sponsoring this video. Kiwico makes these amazing crates tailored around science, technology, engineering, arts, and the maths, otherwise known as STEAM. These crates are awesome. Everything that you need is inside the box, so you don't have to run to the store. I was actually impressed because they even gave me the AA battery to complete this robot. The cool thing about Kiwico is they make all sorts of different crates, depending on your age group and the subject you want to cover. Once you complete your projects, they even have supplemental information in the books to modify your project and to learn even more, or make your robot fly. Fireworks not included. But that's why Tinker Crate and Kiwico is a great learning opportunity if you got kids or if you want to experiment or learn something new or just build around some stuff. These are actually great supplemental information you can give to your kids or yourself if you just want to learn something at home. So these projects are kind of great hands-on experiences because, you know, at the end of the day, I learned best by tinkering and just getting my hands involved with this stuff. If you're looking for a great way to get started with something, try these things out. I'm impressed with these, and they have all sorts of cool ones, and hopefully they actually send me a few more to play with. These products are a lot like things I work on. Everything's included in the box though, and there's a lot less fire involved and all sorts of dangerous stuff. We gotta be kid safe, you know? Alright, so these things are really cool. If you check out the link below, you can save up to 50% off your first month of your Kiwico subscription. Check out the link, it's kiwico.com/peterstreeple and get you one of these things today. So this has been quite an adventure. Man, I'm so happy with it. It flies so great. If you guys want to see more flight footage of this and more raw stuff ahead of time, check out Sam's channel. He's been kind of doing his own thing lately, especially if you want to see early stuff because like you can see this thing flying like weeks in advance. But anyways, thank you guys for watching. Enjoy some more of the smooth B-roll, and I'll see you next time.